Hey, Math 8. So I am going to go over the Chapter 11 practice test. I hope this gets you ready for the test we're taking this week on Chapter 11. The first thing I will do is I will scroll through and give you all the answers, and you can kind of grade your paper. And then I will go through and I will explain how to do each problem, and you can get the help where you need it, hopefully. Make sure you email me if you have any questions. And here we go. So you can see the answers to that page already. And there's the answers to that one. And you can see there. And there is number 7 and 8. And there is number 9 and 10. And there is 11 through 15. And there is number 16. And there is 17, 18, 20, 19, 20, 21. And finally, there's 22, right? All right, so I am going to scroll through and explain them. Here we go. So this first section is about naming an angle. If you want to name this angle, my advice is you trace it. You start at N and then go to C and then go to F. So starting at N would be right here, right? That's point N. Then I would go to C and then I would go to F. And I have made an angle right here, which is angle 2, right? Number 2 says to give the 3-letter name for angle 9. So angle 9 is right here. That means that is the vertex. So, oops, it's this angle right here. So the most important part of this angle is the vertex, is H. So H must be your middle letter. And on one side, I have an I. And on the other side, I have a K or an L. It does not matter. So I started over here, and I said this could either be LHI or KHI, but I could have started on the other side as well. I could have said IHL or IHK. Any of those 4 answers would be correct. All right, something I don't think we went over a whole bunch was that an angle is made up of 2 rays, right? This is a segment. It is a segment because it has an endpoint at both ends. Oops. And this is a line. A line goes forever in both directions. But a ray is kind of a combination of those. A ray has one endpoint, and then it goes forever in the other direction. And an angle technically is made up of rays, right? A ray starts at one point and goes forever. And if you have 2 rays that have the same endpoint, then they make an angle, and there's your angle, right? And that is called the vertex. All right. Number 4. So the key thing in number 4 is that any 2 sides, so typically those would be the 2 small sides, they must add up to more than the length of the 3rd side, which is usually the long side. So if I look at the 2 small sides and they add up to more than the 3rd side, then yes, this thing can make a triangle. But if the 2 small sides only add up to 28 and the long side is 35, think about that. If you have something that is 35 long and you have a 17 and an 11, it's just not long enough to make a triangle. It can't connect. They must be longer than the 3rd side. So 4 and 10 makes 14, which is still not long enough because it has to be longer than the third side. These two guys add up to 14.1, so yes, they're long enough. And these two guys add up to 7, so yep, they're long enough also, right? All right, this brings us to number 5. And the key thing in number 5 is these angles are complementary, which means they add up to 90. So if I take this angle, and I take this angle, and I add them together, I know that they must equal 90 because that's what it means to be complementary. And now I have an equation that I can solve for x. I would add my like terms together. I would add these like terms together. I'm going to subtract 27 from both sides. And then I'm going to divide by 9. And when I divide 63 by 9, I get 7, right? In problem 6, it says that this angle and this angle are supplementary, which means they add up to 180. So if I take this angle and I add them together, it equals 180. Again, I'm going to solve this by adding my like terms together. I'm going to add my other like terms together. I am going to subtract 6 from both sides. And then I'm going to divide both sides by 6. And I think that that is 29. But in this case, 29 is not my answer because I don't want to know what x equals. I want to know what angle ABC equals. So I need to take my x and put it back in for angle ABC. And that way, let's see, angle ABC would equal 5 times 29 plus 14. That would equal 145 plus 14, which is 159. All right. That brings us to the next section, which is knowing these 4 rules, which is really just more vocabulary, kind of. So in this first one, we have an exterior angle, and we have the adjacent interior angle. And frankly, together, those make a linear pair. So they add up to 180. So I know that this is true. And if I subtract 131 from both sides, I get that D equals 49. All right, over here, I am looking for the exterior angle. And in this case, I have been given the remote interior angles. And we have learned a rule that the exterior angle equals the sum of the remote interior angles. So if I add these together, 19 plus 24, that equals the exterior angle. So the exterior angle T must equal 43. Number 8, I have learned that in a triangle, the angles all add up to 180. So if I take this angle, which is 90, and this angle, which is x plus 37, and this angle, which is x plus 67, I know that added together, those all equal 90. So if I add my like terms together, let's see, that would be 104 plus 90, which is 194, plus 2x, I add my x's together, that equals, I have blown this, that equals 180, of course. The angles inside a triangle add up to 180, don't they? Big rum-dum. So then I can subtract 194 from both sides. and I get 2x equals negative 14. And if I divide by 2, I get x equals negative 7. All right. That brings us to number 9. In number 9, I have vertical angles, right? When two lines cross, the angles that are opposite each other are called vertical angles, and they are equal. So if that angle is 45, then this angle down here is also 45. And in number 10, I have the linear pair. So a linear pair is two angles. They have the same vertex, right? They have to have the same vertex. And they share the inside ray. They share that side. But what's most important is the outside of each angle. The outside of 132 and the outside of 2x plus 3 makes a line. And that is why it's called a linear pair. And because it makes a line, I know they add up to 180. So 132 plus 2x plus 3 adds up to 180. And if I add my like terms together, the 3 and the 132, and then I subtract 135 from both sides, and I get 2x equals 45, and then I divide both sides by 2. I end up with x equals 22.5. All right, and then we have 5 examples down here where you might have to go through multiple steps. For instance, if I was doing number 11, right, I can't immediately get the answer. I have to work my way there. The first thing I would probably do is I'd say, well, this is 35, then this must be 35, because those guys are vertical angles. And if I was really good at this, then I would say, all right, I know the answer. This guy is an exterior angle, and these guys are remote interior angles. So the question mark is equal to 35 plus 100, which is, of course, 135. Now, if I don't see that, which some people don't, I could get this angle by using the 3 angles in the triangle. And then I could get the question mark by using these 2 angles, make a linear pair, right? All right, in problem 12, the first angle I'm going to get is this one because these 3 angles in a triangle have to add up to 180, right? So 35 plus 23 plus x equals 180. That would be 58. And so that would be 122. And then I can get this angle is also 122 because those 2 angles are vertical angles, so they're equal. And then finally, this angle and this angle and this angle, in that triangle, they add up to 180. So 27 plus 122 plus x equals 180. That'd be 149 plus x. And so finally, if I subtract 149, I get that angle is 31. Number 13, really the best way to do this one is to say that this is an exterior angle, and it equals the sum of the remote interior angles. So 46 plus 90, which is 136. In problem 14, I think I'm going to have to get this angle first. So I can say that right here at this vertex, this angle and this angle make a linear pair. Right? Their outsides make a line. So that angle must 155 plus x equals 180. And if I subtract 155, I get 25. So this angle is 25. And then I can use this rule I seem to use a lot. This angle is an exterior angle, and it will equal these two added together. So x is going to equal 25 plus 60, or 85. All right, and finally, in number 15, I'm going to get this angle first. I'm going to use the angles in the triangle here. These three angles must add up to 180. So 60 plus 65 plus x equals 180. That would make x equal 55. Then I'm going to use this angle. Sorry about that. This angle and this angle and this angle make a straight line. They are a linear pair, even though there's three of them. So that means that 55 plus 50 plus x equals 180. That's 105. So x would be 75. And finally, I can use the other triangle, that this angle, and this angle in that triangle add up to 180. So 35 plus 75 plus x equals 180. That'd be 110 plus x. So x would be 70. All right. And finally, that takes us to the section on lines crossed by a transversal, where you need to know each of these, as well as still need to know those. So this first section, again, is really just vocabulary. I'm going to color in the angles. So I will start with letter A. And in letter A, I have angle 4 and angle 5. All right, remember, this will always be the case. These are your interior angles. And out here are your exterior angles. So angle 4 and angle 5 are both interior, and they're on opposite sides of the transversal, which makes them, we call that alternate. They are alternate interior angles. This brings us to letter B. This is going to be interesting. So letter B is angle 6 and angle 4. Again, those are both interior, but now they're on the same side of the transversal. So they are same side interior, right? This brings us to letter C. Letter C, I have angle 4 and angle 8. Those guys sit on the same side of the transversal, and they are below their line, right? Angle 4 is below A, and angle 8 is below B. We say they sit in corresponding position. They're both to the right, and they're both below. So that is called corresponding position. Those are corresponding angles. Letter D. Letter D is angle 1 and angle 5. Two in a row. Those both sit to the left of the transversal and above their line, right? So left and above, they also sit in corresponding position, which is like the same position, left and above. This brings us to number 5, or letter E, I mean. So letter E, 5 and 3, those are both interior and on the same side of the transversal, so same side interior. Letter F. Letter F is angle 2 and angle 3. Now that doesn't even use this line down here. So those are, let's see, they are made by two lines crossing, So they are vertical angles, right? Vertical. All right, that brings us to letter G. Oops, mercy. All right, letter G, angle 8 and 5. So 8 and 5. Okay, that is not using this line. So that's only using 2 of the 3 lines. It's either vertical or a linear pair. And what did I say? 5 and 8. So those are vertical angles. They're on opposite sides of the 2 lines crossing, vertical angles. That brings us to letter H, which is 5 and 6. All right, so those 2 again are not using the top line. This time, though, they're not on opposite sides. They sit next to each other. So they make a linear pair. And that brings us to letter I. In letter I, we have angle 1 and angle 3. So that's not using this line down here. 1 and 3 had the same vertex, and they sit next to each other and make a line. That's why they're called a linear pair. And finally, we have angle 6 and angle 3. Those are both interior angles, and they're on opposite sides of the transversal, which is why we call them alternate interior angles. All right, now we want to use these relationships to determine angle measures. So first we have angle 1 and angle 5. So you need to know that angle 1 and angle 5 are corresponding angles. And because they're corresponding angles, they're equal. So if angle 1 is 61, then angle 5 is also 61, right? Next up, we have number 18. Angle 2 is 48. What is angle 4? So that's not even using this line. Those 2 angles are at the same vertex, and they make a line. So they add up to 180. So 48 plus x equals 180. And that is going to make that 152. All right, that brings us to number 19. Angle 4 is 137. And we want to know angle 5. All right, those 2 angles are alternate interior angles. And because they are alternate interior angles, they are equal. So angle 5 would also be 137. And that brings us to the last one, number 20, where angle 6 is 48, and we want to know angle 4. All right, so those 2 angles are on the same side of the transversal, interior, so they are same side interior, and we need to know that same side interior add up to 180. So if I add those together, I get 180, and that makes it, I think I did that one wrong. That makes it, let's see, 180 minus 48, that would be 132. And I just want to go back to number 18 real quick. Number 18, what did I say that was? Angle 2 is 48. Oh, mercy. So that should be 132 also. I messed that up. Okay, number 21. All right, so the first thing I'm going to do is solve for x, which is in these 2 angles. I need to recognize that those are corresponding angles, so they are equal. So 9x plus 25 equals 13x minus 19. And now I can solve for x by subtracting 9x from both sides. Then I would add 19 to both sides. Let's see, that'd be 44 equals 4x. And then I would divide by 4. and I would find out x equals 11. All right. So now that I know x equals 11, if I'm going to solve for y, if I'm going to solve for y, I need to know how big this angle is. So I'm going to take x equals 11 and I'm going to put it in for x. Let's do that. And so I would get 13 times 11 minus 19. That would be 143 minus 19, which would be 124. This angle is 124. And now I can use the fact that at this vertex, this angle and this angle make a linear pair. So that means they add up to 180. I'm going to add them together and get 180. I'm going to add my like terms together. I'm going to subtract 129 from both sides. Let's see, minus 129 would be 51. And I'm going to divide by 17. And I would get that y equals 3. That's what I had. All right. That brings us to the last problem. In the last problem, you want to notice these little guys. These little guys mean parallel. So I guess the first angle I will get is angle 1. I know that if this is 120, that angle 1 and the 120 angle are corresponding angles. And so they are equal. So that's why angle 1 is 120. And then I guess I can go all the way around the circle here. Angle 3 and angle 1 are vertical angles, so angle 3 is also 120. Angle 1 and angle 2 make a straight line, so these two guys must add up to 180, and that is why angle 2 must be 60. And if angle 2 is 60, then angle 4 must be 60 because those guys are vertical angles, so they're equal. And finally, here at the end, this angle was 120, and angle 5 and my original angle make a linear pair, so they add up to 180. So angle 5 would be 60 also. All right, there is an explanation of all the problems. Good luck on the test this week, and I will see you guys later.